The other particular type of symptoms that I think it's worth mentioning is depression. There are some, depression is a very common symptom that patients with schizophrenia experience, but there's also some commonalities between some of the brain mechanisms involved in schizophrenia and also that are involved in just the experience of depression itself. One of those overlapping symptoms is what we call anhedonia, which is an impairment of people's capacity to experience pleasure. Now, I mentioned that a few minutes ago as being one of the negative symptoms of schizophrenia. People with schizophrenia don't get the same rewarding buzz out of life that they would otherwise get. And that's also a core feature of depression. So what we learn from one disorder, we can potentially translate to the other disorder in terms of understanding how we go about restoring that capacity to experience pleasure, because it's really, really important. If you don't get a reward out of going to work, or you don't get a rewarding sense of reward out of your hobbies, you're far less likely to engage in those things. You're far less likely to get out of bed in the morning to find that there's something worth getting on with during your day. So we need to think about that specifically. There's also a bit of an overlap between some of the thinking problems that can occur in depression and schizophrenia. And so some of the things that we've learned in depression can apply here too. One of the particular problematic memory problems that can occur in both disorders is a problem with what we call working memory. Working memory is not my capacity to remember what I did when I was 5 years old, but it's my capacity to remember what happened 20 seconds ago or 30 seconds ago. So if I'm reading something, I need to remember what occurred 2 or 3 sentences ago to make sense of what I'm reading now, so I can follow a paragraph in a sentence or a page. So working memory is really critical to our capacity to learn new things and just to function in daily life. And it tends to be subtly impaired both in depression and schizophrenia. People who are profoundly depressed, I treat a lot of patients in a private hospital with depression at the moment. And when they come into hospital, they'll often have, sort of Who magazine by their bedside. And they'll say to me, I just can't concentrate even long enough to read, a long article in the newspaper, let alone read a book. And as their depression starts to lift, their reading material changes so that hopefully by the time that they're leaving, the novels are appearing and longer material because they can actually focus and follow things through. Now we know, we're learning a lot about the brain mechanisms involved in working memory. We know it involves the front areas of our brain. We're learning a lot about the chemistry, the chemical messengers that are required for this. And we're starting to think about developing very specific treatments to improve this. And these treatments may be useful no matter what the cause of underlying working memory problems. People with Parkinson's disease get problems with their working memory. So we may be able to develop treatments that help this type of problem, irrespective of the illness that's underlying that particular problem. Now, it would be better to have a cure for the disease as a whole. But until we can get that cure for the disease as a whole, if we can find ways of targeting individual symptoms, that's going to improve people's quality of life and their ability to function. So what are our standard sort of biomedical treatments as they currently exist? Well, there's been 2 sort of waves of drug development for schizophrenia, and you may be familiar with some of these terms. The so-called first-generation antipsychotics, or the older drugs, were really technology that was developed in the late 1950s and the early 1960s. There were a whole lot of drugs, but they were very, very similar. They did exactly the same thing. They had slightly different side effects, but they acted in fairly similar ways. They acted by blocking one particular chemical in the brain, and that was kind of all that they did. They were the drugs that, because they blocked that chemical relatively indiscriminately, that could cause a lot of motor side effects, tremors and rigidity, some involuntary movement, muscle spasms and the like. And it was kind of almost too late in the day that we realised that those drugs were actually being prescribed at doses that were probably too high. With what we know now, if those drugs were being prescribed at much lower doses, we probably would have had far less of a burden of side effects than actually those medications occurred. Beginning in the mid-1980s, a second generation of antipsychotic medications came about, and there's been a sort of family of these, and these are really the medications that are widely used for treatment of schizophrenia today. These are a slight advance on the first generation of medications. They're not revolutionary, unfortunately. They, generally speaking, have far fewer of the side effects that the older medications have, but they have their own problematic side effects. Weight gain in particular has been one of the problems with this newer generation of medications that patients find quite quite difficult to deal with. Some of them are sedating. But the one advantage of this group as a class is that the side effects do vary across the drugs. And so for most people, but certainly not all, it's reasonably likely that we're able to find a medication that patients can tolerate and will benefit their symptoms. But as I said before, it will primarily benefit the positive symptoms and not the negative symptoms and the cognitive symptoms that come about with this particular disorder. So things got a bit better, but we really need to go far further than we've got so far. Where are things going to go with medication delivery? Well, fairly recently we went through the so-called decade of the brain. And there was an enormous excitement generated about brain research in the 1990s and particularly in the 2000s. There's been an explosion of knowledge of genetics. We've got really powerful neuroimaging tools now that allow us to map the brain. It allows us to take detailed pictures of the structure of the brain, of the function of the brain, what areas are active when we do certain tasks, and also to actually map the connections between different brain regions. Some of these tools are extraordinarily powerful compared with what we could do 10 or even 10 years ago. And so with that excitement, there was a real sort of burgeoning of interest that this was going to lead to a kind of an explosion of new treatments for neurological and psychiatric disorders. That's kind of partially come true, but it really hasn't kind of fully been expressed so far. What's kind of in the pipeline now, what's likely to become available in the immediate future from sort of big pharmaceutical industry is not really a major advance on what we've got at the moment. There are a series of similar second-generation medications, some of which might have better side effect profiles that will probably be released over the coming couple of years. But unfortunately, none of those medications are likely to be a really major advance. Which is really what it is that we actually need. You probably can't see this slide, but it tells a slightly unfortunate tale. It was from an online publication in Science magazine, I think it was last year. And essentially what they did was they compared a couple of factors in new drug development. They wanted to look at how long it took to develop a new drug right from scratch, from when someone makes a new discovery in the test tube or the laboratory through to when that drug gets used in patients, how much it cost, and also the likelihood of a new discovery actually leading to a successful new drug. And what they found was when you look at drug development for psychiatric and neurological disorders as a whole compared to, say, heart disease or diabetes or asthma, it takes longer to get a new drug to market. Our success rate is the lowest of all the areas, and it costs the most, which is kind of a little bit disencouraging. But despite that, there continues to be a major investment in this process. But it's something that's going to take quite a long time for that strength of sort of neuroscience that's happened in the last 10 or 15 years to actually flow through to new treatments. People estimate that it can take up to sort of 15 or 20 years for a kind of discovery to actually adequately be translated. So what do we do in the meantime? Well, we've got some clues about where we're going to be going. There's a variety of other chemicals in the brain that are good targets and people are actively investigating. But as I said, it's going to take some time. So what do we do in the meantime? Well, within our research centre, our kind of focus is not on doing laboratory-based research and trying to discover, say, the gene for schizophrenia, but it's about saying, okay, let's try and fill that gap. Let's try and develop treatments at a much shorter time frame that can help patients whilst we wait for those really curative developments to occur, which might take some time. And so how do we do that? Well, we do that by trying to think a little bit out of the box. We do it by trying to take already existing medications that might be available in other areas and think about how that might be applied to psychiatric disorders. And we try to think about other sort of novel compounds that people use. And we have a whole range of research into a whole different type of way of intervening in psychiatric disorders that I'll spend a fair bit of time talking about in a minute. But a couple of those ways that we've been involved in, for some reason my slides about the glycine trial disappeared off my presentation, but I'll just talk about it briefly. Glycine's actually an amino acid. It's a basic building block of protein. You can buy glycine in the health food store, although most health food store preparations aren't necessarily well quality controlled, but it's something that's freely available. some very clever researchers a few years ago, when they were trying to develop a way of manipulating one particular neurochemical in the brain, discovered that if you gave glycine, you could actually increase the way in which the brain, some of the nerve cells talk to one another, in a way that seemed to have really relevant relevancy to the treatment of schizophrenia. And so some researchers both in the United States and at our centre, we've been invested in investigating whether glycine, this sort of health food preparation, can actually improve the symptoms of schizophrenia. What it seems to do is, interestingly, it doesn't seem to do a great deal for the positive symptoms, for the voices, for the problems with thinking and the confused thoughts and the false beliefs. But it does seem to make an impact on the negative symptoms, on drive and energy and motivation, and also on some of the subtle cognitive problems that people experience. It's still very early days. Unfortunately, when you give too high a dose of glycine, it makes people feel quite nauseous. So we have to kind of spread the doses across the day. And I think ultimately, fortunately, the pharmaceutical industry is now invested quite heavily in developing drugs that might be better tolerated, that will kind of mimic glycine in the brain. But in the meantime, we can potentially use this. So we've got research going on at the moment to try and evaluate this and to kind of extend this over the next couple of years. So that's something certainly we're interested in.